So the last thing I'm going to talk about in this section are some fluid forces. And I'm going to start with a couple equations here for you. And the first one has to do with pressure and depth and weight density. And it says in a fluid that is standing still, the pressure P at depth H is the fluid's weight density W times H. Weight density in the English system, which again is what we use here in the United States, that weight density W is going to be given as pounds per cubic feet. So W will be in pounds per cubic feet. And typically, at least in here, that is going to be given to you. And you can think about this. If you've ever been swimming in a pool or in the ocean, the deeper you go, you can feel that water pressing down on you with more force. That water pressure gets stronger the deeper you go. And that's what that equation is dealing with. Now we can apply that to find the fluid force on a constant depth surface. So if you will, imagine a swimming pool and the bottom of the pool is 4 feet under the surface of the water. This second equation here, which is labeled equation 5, that would give you the force on the bottom of that pool, okay? And the force is just going to be the pressure P times the area, okay? The area of the bottom of that pool, if you will. We're gonna look not at that kind of constant depth, but we're gonna look at, well, what happens if you stand something up inside that pool? So instead of looking at a flat horizontal bottom of a pool, what if you stand something up? So it'd be standing vertically. And that's what we're going to look at here with this kind of third formula. It says fluid force against a vertical flat plate. Suppose that a plate submerged vertically in fluid of weight density W runs from y equals 0 to y equals b on the y-axis, because again it's standing vertically. Let L of y be the length of the horizontal strip measured from left to right along the surface of the plate at level y. Then the force exerted by the fluid against one side of the plate is given by this. The force is the integral from A to B of W, which is the weight density, that's going to be a constant, times the strip depth, and that's typically just going to be y, times the length of that horizontal strip, dy. So let me show you an example here, and hopefully it'll help you make a little more sense of this equation. It says a flat isosceles right triangular plate with base 6 feet and height 3 feet. So in the diagram here, you can see the triangle. Excuse me. It's submerged base up 2 feet below the surface of a swimming pool. So this would be the value of y equals -2, and it's marked here on the diagram. Find the force exerted by water against one side of the plate, and then it says note the water density of water, or sorry, the weight density of water, not the water density of water, is 62.4, and that would be 62.4 pounds per cubic feet. So this is our value for W. Now we need the strip depth and then our value for Ly. In this case, we're looking at the surface of the pool being the x-axis. So we're going underneath that into negative y values. So when we talk about the depth, it's actually going to be negative y. So if we're talking about 2 feet below the surface of the pool, in this picture here, that would be represented by y equals -2, but we say it's just positive 2 feet below the surface. So my strip depth is going to be -y. And actually, I can start to fill in this. So we've got 62.4. The strip depth is negative y. And then I want to find this ly. That's the length of a horizontal strip. So that's what is marked here as a red rectangle. So how do I find the length of the strip? Well, if you notice, I have this dashed blue line here. And if we can find the equation of the line, and we can, it's actually pretty easy to find, that x value from the y-axis to that x value would be half the length of that strip. So if I can just double that x value, I've got my ly. This diagonal line here, okay, it goes through the point 0, -5, and the point 5, 0. You can use those 2 points to find the slope. It's got a slope of 1, and the y-intercept is -5. So the equation of this line is y equals x minus 5. If I were to rewrite this and solve it for x, we would have x equals y plus 5. So that means this point xy, I could rewrite it as y plus 5, comma y. So that means the distance from the y-axis to this point is y plus 5. So the total length of this strip, so the total length of this red rectangle would be twice that, so 2 times y plus 5, and that's my ly. So my bounds here, my upper and lower bounds, when I integrate, the very bottom of the triangle is at y equals -5, and the top is at y equals -2. Now, kind of looks like a bit of a hot mess right now, so let me clean things up a little bit. I'm going to take the 2 times the 62.4 times that negative and bring that to the front, okay? So that's going to give me a negative 124.8 in front of the integral. So we're going from -5 to -2. Once you pull out the 62.4, the negative, and the 2, you're simply left with y times y plus 5. So that's y squared plus 5y. And we can very easily integrate that. We're going to end up with y cubed over 3 plus 5y squared over 2. And again, I'm going to look at that from -5 to -2. So plugging in, what do we have? Starting with my -2, I'm going to have -2 cubed, which is -8 over 3. -2 squared is 4. 5 times 4 is 20. So I have 20 over 2. And I know that 20 over 2 is 10. There's a reason I'm keeping it as a fraction. You'll see in just a second. So moving down to the -5, -5 cubed is -125. That's going to be over 3. -5 squared is 25. 5 times 25 is 125 again. So we have 125 over 2. I'm going to now combine like terms, or terms with, they're all like terms. Let me rephrase that. I'm going to combine terms with the same denominator. -8/3, and then I have a minus a negative, so it's going to be plus 125/3, leaves me with 117 over 3. Then 20 over 2 minus 125 over 2 is going to be minus 105 over 2. $117 over 3 is just 39. 105 divided by 2 is going to be a minus 52.5. So I'm left with just a negative 13.5 from those parentheses. And finally, we just multiply, and we're going to end up with 1,684.8. And since this is using feet here, the force here is the force in pounds.